Hello friends. So now in this video we will be seeing with the next algorithm, that is your preemptive priority scheduling algorithm. Okay, in the previous video we saw with priority scheduling algorithm with a non-preemptive nature. So now in this we'll be seeing with the priority scheduling algorithm with the preemptive nature. Preemptive nature means what? If the process is currently executing, so if there is any other priority schedule, if any other priority process comes into the queue, so this will be terminated and the CPU will be given for the other process over that. Okay, so that means in between, if the process has been forcefully stopped, we call it as preemptive. That's what we have discussed in the previous videos. Okay, so quickly we will be moving with the solving of your problem over there. So here the given data is processes. We are having 7 processes over here, and each process is given with the priorities 2, 6, 3, 5, 4, 10, and 9, and the arrival time is given there and the burst time is given. Okay, so this is the given data for the process ID, arrival time, priority, and burst time, right? So what is to be calculated? What is the completion time? What is the turnaround time? What is the waiting time? And calculate the average turnaround time and average waiting time. Okay, so to do all this, the first thing what we have to do is draw the Gantt chart. Okay, so how it is different from non-preemptive? Let us try to understand using this Gantt chart over there. Okay, so first thing what we have to do is we have to see the arrival time, right? So at zeroth time, how many processes are available for us for the execution? If you see at the zeroth time, if you see here, scan the entire arrival times over there. At zero time, there is only one processor, that is P1, available for us, okay, in the queue, right? So let us assume this is the queue over here. Initially, as only P1 is available, so directly CPU will be taking this P1 for the execution. Okay, so now when P1 is given for the CPU, what is the burst time of P1? It is just 1, right? So now once P1 starts its execution, after 1 unit of time, it checks is there any other processes are into the queue. At the 1 unit of time, we can see here the next process P2 is there into the queue, right? P2 is just here into the queue. Now, if you just observe here, the process P1 burst time is just 1. So definitely it has completed its execution. Even though if it has not completed execution, we need to check, as P2 is there in the queue now, we need to check the priorities of P1 and P2, right? So definitely P1 wins the race over there. But here if you see, P1 is having only one burst time, so it has been completed. So which is the next process which will come into existence? That is P2. P2 starts its execution now, so it is no more in the queue, correct? So now P2, when it starts the execution, so it starts the execution at 1 unit of time. From 1 unit of time to second unit of time, it continues with the execution, because at the second unit of time, if you see here, the third process is into the queue. The third process is into the queue. If you see there now, the third process, when it enters into the queue, what is the priority of that third process? The process, the priority is 3. Now, if you observe, what is the priority of P2? It is 6. What is the priority of P3? It is 3. Who is having the less, who is having the, what you can say, least number? Definitely 3 is lesser than 6. So who is having the higher priority? As I have told, lesser the number, higher the priority. Less the number, higher the priority. Higher the priority. Okay, if this is the case, so definitely process 3 will take the control of the CPU now. When process 3 takes the control, the burst time of process 3 is how much? 3 units of time. But it will not, when it starts its execution, if you see at the third unit of time, from one, when it executes 1 unit of time, that is at 3, which is the process which enters into the queue now? It is P4. Process P4, which is entering into the queue, right? So when P2 has been terminated, so P2 has been entered into the queue and P3 has been started with the execution over there. Okay, just remember that, right? So P2 is into the queue and P4 is also into the queue. So once the P3, when it checks at the third unit of time, P4 is, sorry, third unit of time, P3 is there. Okay, P3 has been came into the existence. Third unit of time, P4, sorry, when at the third unit of time, P4 has came into the existence. We will push into the queue, but not for the execution because the priority of that is what? 5, right? It is not less than 3. So it will be staying into the queue, not coming back to the execution. So at fourth unit of time, which is the process which comes into queue? P5. Okay. P5 will hold into the queue or start the execution. No, it will not start the execution. Why? Because P5 is having the priority what? 4. It is also not less than 3 because P3 is currently running with the priority what? 3. So 3 is definitely less than 4 and 5. So definitely this is having still the highest priority. So P4 and P5 will stay in the queue until and unless P3 has been executed. Now at the fifth unit of time, if you see, the burst time of P3 has been completed and P3 completes its execution. So at the fifth unit of time, there is one more process P6 which comes into the queue now, right? So P6 also comes into the queue, correct? So now totally, when P3 completes its execution, which are the processes which are in queue? It is P2, P4, P5, and P6. Correct. So if you look into this, P2 is also there in the queue, P4 is also there in the queue, P5 is also there in the queue, and P6 is also there in the queue. Looking at all this, tell me whose priority is having the lesser number. It is 6, it is 5, it is 4, and it is 10. So definitely P5 is having the lesser number. Lesser the number, higher the priority. So which is the next process which will start its execution? It is definitely P5. That is why here P5 starts its execution over here. But when P5 starts its execution at the sixth unit, there is one more process, P7 enters into this queue. Right now, P5 has taken the control, so delete it from the queue. P5 has started. At the sixth unit, when P7 enters, check the priority. Is it less than the number of P5? The P5 is having how much? 4. Definitely 9 is less, not less than 4. So there is no need to terminate this P5. So it continues till the completion of the burst time. So what is the P5's burst time? P5's burst time is 5. So 5, it has started at 5 unit of time. 5 plus 5 is 10. It will complete at 10th unit of time. When it completes at 10th unit of time, you need to go back to the queue. Which are the processes in the queue? P2, P4, P6, and P7. Okay. Out of P2, P4, P6, P7, which is that process which is having the lowest number, right? So now P5 has completed its check with P2. P2 is 6, P4 is 5, and P6 is 10, and P7 is 9. So definitely here, if you observe P4, that is 5 is the lowest. Out of 6, 5, 10, and 9, P5 is the lowest number. So this will take the charge because P4 is having the highest priority now. So P4 completes its execution. What is the burst time of P4? It is 6. So 10 plus 6 is 16. Till 16 unit of time, this will complete. So P4 has been completed its execution. So what are the processes in queue now? P2, P6, and P7. Out of P2, P6, and P7, that is, what is the priority of P2? It is 6. What is the priority of P6? It is 10. What is the priority of P7? It is 10. So definitely P2 executes, then P7, and then P6. See here, P2 has been executed, P7, and then P6. So this is how we are drawing the giant chart in primitive priority algorithm. Okay. So once the Gantt chart has been drawn, it is quite easy for us to come up with the completion time. Completion time is quite easy. Process P1 has completed its execution at first unit of time. P2 has completed here. P2 is partially completed here and it is completed at this point. Okay. So P2 has completed its execution at 22nd unit of time. P3, check P3, is it partially? No. P3 has taken the entire control of CPU and it has completed at fifth unit of time. And P4, if you see here, it has completed at 16 unit of time. Similarly, P5 has completed at unit number 10. Then P6 has C. This is the last process to be completed. It is 45 and P7 has completed at 30. So completion time has been calculated. If once the completion time has been there, we can easily calculate the turnaround time. The formula for turnaround time is what is completion time minus arrival time. What is completion time of P1? It is 1. What is the arrival time? It is 0. So 1 minus 0 is 1. Completion time of P2 is 22. Arrival time is 1. So 22 minus 1 is 21. Completion time of P3 is 5. Arrival time is 2. So 5 minus 2 is 3. Similarly, calculate the turnaround time for rest. What is the waiting time formula? Waiting time formula is turnaround time minus the burst time. Okay. So what is the turnaround time of P1? It is 1. What is the burst time? It is 1. 1 minus 1 is 0. What is the turnaround time of P2? 21. Burst time is 7. So 21 minus 7 is how much? It is 14. Correct. So what is the burst turnaround time? It is 3. 3 minus burst time is 3. So 3 minus 3 is 0. The turnaround time of P4 is 13. The burst time of P4 is 6. So 13 minus 6 is 7. So similarly calculate the waiting time for rest others. Okay. So if I want to calculate the average turnaround time and average waiting time, so please sum all these turnaround times and divide it by the number of processes, that is 7. And waiting time, average waiting time, sum all this and divide it again by 7. You will be getting the average turnaround time and average waiting time. Okay. So hope you have understood it. Okay. So see you in the next video with the next algorithm. Thank you. Thank you.